Okay, in this video we're going to look at about 4 examples of adding and subtracting rational expressions where you have uncommon denominator. And this one's a little bit trickier because we have to find the common denominator, which is least common denominator, or it's the same thing as LCM, least common multiple. So in this one I have denominators of 15x squared and 24x, and they're not the same. So what I'm going to do is I'm going to say, well, 15x squared, 15 is 3 times 5, and then times x squared. 24, if I do my little factor tree, 24 breaks down into 2 and 12, breaks down into 2 and 6, breaks down into 2 and 3. So here I would have 2 to the third times 3. So 24 is 2 to the third times 3 times x. So least common multiple, I'm going to need one of each factor, and then the highest power of each factor. So I'm going to need a 2, a 3, a 5, and an x. Those are my factors. Highest power of 2 is 2 to the third. Highest power of 3 is 3 to the first. Highest power of 5 is 5 to the first. Highest power of x, x squared. So LCM here is going to be 2 to the third times 3 times 5 times x squared. If I multiply that all out, it's going to be 120x squared. And that's what I want to make my denominators look like, so that I have a common denominator, so then I can add my fractions. So we have 7 over 15x squared, and to make 120, I need to multiply by 8. It's already got the x squared, so just by 8. The second one, we have 13 over 24x. And I need to multiply by 5, and then to make an x squared, I need to multiply by another x. Okay? And then you're already very good at multiplying fractions, so we would have 7 times 8 is 56 over 120x squared plus 65x over 120x squared. We have common denominators, so we can go ahead and add the numerators, and then all over the common denominator. And I would look to factor the 56 and the 65, but they don't have anything in common, so that's it. That's all I can do, and I roll on to the next one. So we're going to look at 4 over x minus 3 plus 7 over x plus 1. So my denominators are x minus 3 and x plus 1. They're both distinct, so I'm going to need one of each. So my LCM is just going to be x minus 3 and x plus 1, and that's what I want them to. That's what I want my denominators to look like. So the 4 over x minus 3, it's missing an x plus 1, so we're going to give it an x plus 1. So multiply top and bottom by x plus 1. So that doesn't change anything. X plus 1 over x plus 1 is 1, so we haven't changed the fraction at all. Plus 7 over x plus 1. And we're missing an x minus 3, so we're going to give it an x minus 3 over x minus 3. And we'll go ahead and multiply. So we have 4 times x plus 1 over x minus 3, x plus 1, plus 7 times x minus 3, all over x minus 3, x plus 1, or x plus 1, x minus 3. The order does not matter. Now we have common denominator. Distribute, and we have 4x plus 4 plus 7x minus 21, all over your common denominator of x plus 1, x minus 3. Combine the 4 and the 7 to make 11x. The 4 and the minus 21 gives me negative 17, all over my common denominator. I go ahead and I try to factor, but there's nothing to factor in the numerator, so that's it. We're done. We move on to the next one. We have 17 over y plus 4 minus 18 over y squared minus 1, or sorry, not minus 1, minus 16. So down below I'm going to find the LCM. There's y plus 4, and then y squared minus 16 is going to factor into y minus 4, y plus 4. Okay, and my LCM So I'm going to need one of each factor. So my factors are y plus 4, y minus 4, y plus 4. So we're going to need one y minus 4 and one y plus 4 because everybody's to the first power. Okay, so we want everyone to look like y minus 4, y plus 4. Okay, so that first fraction, the 17 over y plus 4, all it's missing is a y minus 4. So we're going to multiply it by y minus 4 over y minus 4. And the second fraction, I don't got to do anything other than factor the denominator. It's already good to go. Okay. So we have 17y minus 68 all over common denominator minus 18 over common denominator. So we will have 17y, and then minus 68 minus 18 will be negative 86 all over y plus 4, y minus 4. We try to factor the numerator, nothing to do. We're done. We got one more to do. Okay, so we're going to look at 3 over y squared minus x minus 20 plus x over 2x squared plus 7x plus 4. So we don't have common denominators, so we're going to go ahead and factor both denominators. So x squared minus x minus 20 factors into x minus 5, x plus 4. 2x squared plus 7x plus 4, or minus 4, I'm sorry, factors into 2x and x plus 4, and 2x minus 1. So I'm going to look for the LCM there, so I need one of each factor. So I need an x minus 5, an x plus 4, and a 2x minus 1. They're all to the first power, so I just need one of them. One of each. Got x minus 5, x plus 4, and 2x minus 1. Okay. So the first fraction, I'm going to go ahead and factor the denominator. And what it's missing is a 2x minus 1, so that's what we'll multiply the top and the bottom by. Plus, the second one, we'll go ahead and factor that denominator, so it'd be 2x minus 1, x plus 4. And what is missing is an x minus 5, so we'll go ahead and give it the x minus 5. Okay. So then if I distribute, we'll have 6x minus 3, and then for the second fraction we'll have x squared, and then it should be minus 5x. Okay, because I'm out on a limited amount of real estate here, I'm going to be a little bit more efficient here. All over the common denominator. It doesn't matter the order of how I write my common denominator. Multiplication's commutative. Okay, so I'll have x squared plus x minus 3 all over x minus 5, x plus 4, and 2x minus 1. I do try to factor the numerator. It's not going to factor. Nothing we can do. That's it. So we're done. And well, it's probably about close to about as difficult as they're going to be. But you know, if you just factor denominators, find the LCM, make the denominators look the same, and then all you got to do is add or subtract your fractions, and you should be in good shape.